the aluminum can block the nutrient uptake. And mostly though, it's not going to kill the trees directly. However, it will make them a lot more vulnerable to other things like cold winters, air pollutants, insects, disease. And so how it does this, there's the soil degradation at the Hubbard Brook Experimental Forest in New Hampshire. They tested the soil and found that there were extremely low levels of calcium and magnesium, which are essential for growth. And in Vermont, they found also that acid fogs and rain were leaching calcium and spruce directly from, were leaching calcium directly from the spruce needles on the pine trees, or on the spruce trees. And as I said before, there's the release of aluminum, which blocks nutrient uptake. So here we see before 1880, it was the amounts of aluminum and hydrogen ions were low, and they weren't reaching the deep soil. But now, well, in 1980, it's a lot better now since the Clean Air Act. Then the aluminum, calcium, and hydrogen ions, as well as potassium, were going through the soil. They were reaching the deep soil because of, I have it here. Yeah, with the lower acidity, the rainwater reacts with the soil, the sulfuric acid does, and that allows the aluminum to reach the deep soil, and that's toxic for the trees. As well as the calcium and potassium are now running off into the streams more. And so what is the buffering capacity? That's just the soil's capacity to neutralize the acidity of acid rainwater. And different areas have different buffering capacities. In the Midwest, it's much stronger, and then in the Northeast, the soil's buffering capacity is a lot weaker. And the effect on humans, it's not so much a direct effect on human beings because we can swim in acid rainwater and be fine. We can get rained on. We can even drink it. But one thing is that SO2 and the NOx fine particles have effects on breathing. So you can get asthma and bronchitis from breathing these things in. So it is important to reduce these emissions, which is happening because they directly cause effects on human health. So also decreasing the NOx particles will reduce the formation of ozone.
Okay, so we just told you that pH of acid is really low and is affecting a lot of ecosystems. So we're now going to talk about what is being done to decrease SO2 emissions and NOx. So this is a scrubber installation at a typical power plant, and scrubbers essentially act as filters. So the combustion gas are forced through a spray of water containing lime, which is calcium hydroxide. And this sulfuric dioxide gases that results from just coal being burned in incomplete combustion will forcibly react with the lime that's in the spray of water, and this produces a solid calcium sulfate. So that way, instead of being released in the atmosphere, it's trapped because it becomes a solid. And the pros of this is that it removes 80 to 95% of sulfuric oxides, but it doesn't remove nitrogen oxides, and it's really costly to install one of these scrubber installations in already existing power plants, and it also increases electric generating costs by 10 to 50%. And also, it creates a really nasty sludge that's really hard to store, so there's problems with that as well. Another way to reduce emissions is a fluidized bed combustion, and it's a turbulent bed of vaporized coal and limestone suspended by an upward blast of air. And the combustion chamber has many boiler tubes which convert water into steam. This allows coal to be burned at a lower temperature, which reduces the NOx compounds that are formed. And the limestone, which is suspended by the upward blast, will react with sulfur oxides which converts them to calcium sulfate, which is a solid rather than gas. And this is like a really good way to reduce emissions because it allows coal to be burned more efficiently, and it removes most of the sulfur oxides and NOx compounds.
Right, that's it.